What are capture the flag challenges anyway? First of all, it's about hacking, as you all guess, and then capture the flag is like a scoring system of the challenge, so that finally you end up in a setup where there are multiple teams competing and hacking each other, and you got a kind of a system to evaluate who performs best, so that, well, in the best case, you would have a full ordered system in the end where you see which teams performed best. Yeah, how does this work exactly? Typically each team receives a server image, which they have to set up. The server image deliberately contains a lot of vulnerabilities. Most of them are quite trivial, some are harder to detect. And if by the time the contest starts, all teams have to find the vulnerabilities in their own images, trying to fix them out and exploit them at the other teams, so that if you found a vulnerability, you can try to get into the other team's systems. If you get into a system, you typically find a lot of information there. Some of them is deliberately left there by the organizers of the system, and you can submit it in a central location to prove that you hacked another system. For every piece of information that you submitted, you receive scores, and you actually transfer the scores from the defending party's amount of scores to your own scores. So the more flags you get, the more scores a team gets, and I think we end up with no slides at all. So okay, so now there we are. Yes, the services are tested for functionality every now and then by the organization, of course automatically by the scoreboard. If the services are not up and running, which is one of the central points of the contest, then a team of course gets no defensive points. So one of the possibilities to get better than the other teams is just trying to disturb the availability of their services. The second possibility is just hack into the services and steal the information that is left there by the organization And the third, of course, is to have your own services running all the time, not being disturbed by the attacks of the other teams, despite of the vulnerabilities that they are included in the source code. A third possibility to get points, which is quite new in the kind of CTF games, is that if people find vulnerabilities, they are encouraged to write advisories and send them to the organization. These advisories are then scored for style and completeness, which again is a third kind of scores. These scores are then all added, and well, we know that. Then why should I waste my time to play these games? The first, but obviously wrong, is to win it. The actual motivation to play capture the flag games is to learn new ways of exploitation, to learn getting hit by exploits, and of course to have fun. Then what do you learn in these games? Of course, they are not for real professional hackers. They are more for designed for students and those who want to learn hacking. Well, first you train your programming skills, because in these games you'll meet source code that was written by other people, and well, of course, admittedly, it's typically written in a very bad style, but you learn how other people write and you learn how to make it better. Then typically you learn or you develop on your own very innovative defensive skills, how to defend a system that contains as many holes as a Swiss cheese. You learn to work under pressure. And I think the most important is that people see where software breaks in real scenarios. Well, if students learn security in universities, they typically just learn that deploying certificates, deploying encryption leads to a 100% secure software. This is obviously not the case. So here's the point where we teach students at which point software really breaks in real systems. Then what won't you learn at these systems? It's real-life pen testing. Real systems work a little bit different than these capture the flag games, but we've seen that in the last talk. Then if you want to participate in the capture the flag game, the first thing you need is someone to set it up. The organizers need to have really a lot of spare time to set up, because as we'll see later on, all the services that are deployed in these capture the flag games are typically custom written. They are not something like ready to take buggy Apache like 1.0.0.0 alpha pre-release 1. So you need a lot of time to write these systems. Typically, you would like to know as an organization, as a hoster of these games, where the software will be break. So you need the expertise of exploiting the systems on your own. You need to be vicious to insert some really hard to find bugs, so that people after a while will recognize that they're getting exploited, but they don't know where it is. And of course, there are a lot of questions in these games, so being responsive is obviously a plus. For the players, if you participate, it seems trivial to say that people should know basic exploitation techniques and they should know about defending systems and programming, but in my experience of capture the flag games, there are teams where not a single participant could program. There are teams that can't set up IP tables. There are teams who gave away their root passwords to the administration. There are teams, well, this list could be really long, but so if you, I think one of the best things to do actually for future capture the flag games would be to set up page where the teams submit their participation request, and they already would have to solve some minor SQL injection or something like that just to sort out the strong ones from the weak ones. Our experience is also that if you want to set up a capture the flag game, it's futile to have teams that are larger than 10 people or smaller than 5, because in one way you would end up with having less manpower if you are less people, or otherwise you would have so many internal communication problems that some problems are not covered at all, or a lot of people tend to do the same and don't recognize it. And of course, players of capture the flag games would need to be able to read and understand English text, something that is not obviously, because like only 10% of all the players read the rules, read what a flag is, read how the scoring system works. Otherwise it's not able to explain how the outcome of some capture the flag games is. So if you're up to host a capture the flag game, or if you're going to participate, take all the information that's available, read it once, or at least, or even better, twice, just to be sure that you didn't miss a point. Of course, capture the flag games need to have rules, although being a hacking challenge would imply to some people that the absence of rules is a must. We need to have some rules because fun is one of the crucial parts of the game, and if everybody just does what they want, that the complete game will end up in havoc. First of all, we got a very good experience with explaining all rules before the game. Otherwise, if there's a referee decision on unethical behavior, players will just complain, and well, the fun is gone. We also suggest that unethical behavior like deleting vital system files or shutting down other people's servers should not be done, because the time for recovering from these heavy blows takes too long for a typical capture the flag game, so that the fun from the team that is hit is just gone. And well, this is just plainly not fair play, and if I have a root shell on another system, it's a much better use for it is just to install a kernel level backdoor or whatever, and just getting all the flags from the system. Yeah, but anyway, enforcement of any rules is typically not possible, because in some ways the players are distributed all over the game and just connected all over the world and connected by VPNs, so that if I'm not there, I can't check whether their system contains some illegitimate firewall rules, or whether they do some other kernel level filtering or contain pucks, SE Linux or whatever. So just anyway, logging is suggested at the central point, just to make sure that if some team misbehaves, then you can prove it later on. Then other typical rules are that just cheating on the team size is well, trivial. I think, like, if I have a rule that says no teams above 10 people and there's one team having 20 people, then this team of course has an advantage. So the problem is again that it's typically impossible to prove that a team in a remote capture the flag game has a certain team size, so just have to believe that. Intentionally supporting other team is the same. Yeah, just sticking to the last one, that no automated stack protections techniques or other things like that are allowed in capture the flag games, because the participants are not supposed to work around flags with vulnerabilities without understanding them. So these will destroy the fun of the game, so it's forbidden. The same applies to denial of service attacks that just drop down the availability of other teams without really making the attackers understand why or how they shut down the other system. Just skip a little bit because we're back in time. Then, sorry. Yeah, the basic thing about all capture the flag games are the challenges. Each challenge is typically consisted of a single service that is connected to the network so that the other teams can access it. There are some very simple rules about these services that would have to be deployed or at least ensured while writing these services, just to make sure that the fun remains in the game. The first is that under any condition you have to avoid a root exploit on the system. Otherwise, if somebody hacks this service and gets root shell, he can delete the system, he can read all the information from all services and not only from the one he compromised. So well, this is just to be avoided, otherwise he would have an unfair advantage. Then the reason not to take out-of-the-box services is, of course, that there's no time to develop zero-day exploits in the capture the flag games. And that we don't want to enforce participants looking for vulnerabilities using Googles or just like experienced players knowing the vulnerabilities from databases like Bugtrack. Instead, players should look for the vulnerabilities on their own. We also just can't modify these services because otherwise people could just download the original source, do a diff, and then they got all the vulnerabilities. So as I already said, we have to stick up with writing custom services, typically using standard protocols because these are known to the players and the players can develop very fast a good feeling for what a service does and where the vulnerabilities are. The programming languages in the capture the flag should be adopted to the typical use of systems that can be found somewhere. Of course, PHP, Perl, C, Bash, and so on, they are encountered in nearly every capture the flag. In some occasions, there's Java and Python, quite unusual and never seen, or BASIC and Pascal languages. This doesn't mean that they will never occur in a CTF, just they're quite uncommon, and if the hoster of a CTF game wants to add a little spice, they can just use unusual programming languages. To the difficulty of the task, it's so that the capture the flag games are not designed for professional hackers, as I already said in the beginning, but for students. So there have to be vulnerabilities that are so damn stupid that they will never occur in a normal course, in a normal source. This is also a little bit important for the bootstrapping of the game. Otherwise, people just analyze the code and there's nothing happening in the first 3 hours. So we want to change that because, after all, capture the flag games are about fun. And another reason to avoid just services that only contain very difficult services is that the time of the hosters and the time of the players is precious, of course. We want to avoid that they start analyzing code and there's no result until the end of the capture the flag. This, again, is something that has to be avoided. Unfortunately, in the experience, it's that there aren't just two easy tasks. In nearly every capture the flags, there are some programming lines like system quotation mark ls star or some ls system calls in C files or in Perl scripts that can be very trivially used for shell injection, but there are always some teams that never fix them until the end of the game. So I think maybe that some teams should better not only do the capture the flag game itself, but only analyze what happened to their image during the game, and learn from it for the next time. So this could improve something. I think I could show some examples of capture the flag services, or at least part of them. Here's a part of a guest book that has been used in the ICTF2 from the UCSB University, where we see a typical CTF style programming where we have a Perl script, a Perl CGI that copies everything to global namespace and then just uses a shell command. Again, this is something where some teams are unable to fix it, but most teams get that they just have to replace the first lines with just copying the interesting parameters and then just filter out all evil shell escape characters. Another vulnerability that is sometimes used in PHP is just taking hidden content from the user and then executing code that is typically not executed during the normal course of the scoring system. This part is these lines are taken from the ICTF 05 that has just been happened in the beginning of December, where there was just a file that has never been used by the scoreboard, and it was in the same directory as all the other files that were patched and checked by the players. But since it wasn't used by the scoreboard, most players didn't took a look at it, and well, it contained something that's just kind of a trivial backdoor where you only have to enter the service name in a cookie and it lists all the flag. Another damn stupid style of programming, well, we already got that. Yeah, it's the same. It's just not system, but popen with basically the same. That sometimes it's quite nice to have these lines where you enter just one line of shellcode, and it's quite difficult to replace with the original programming language. In this case, it would be easy, but if it's not just a cat but a grab or whatever. Yeah, just some more. Oh, yeah. And then there's, of course, the more advanced vulnerabilities where we have these chat server where you could have a channel, and what people didn't recognize was that the channel that you joined where the flag was posted was not checked as a string but as a regular expression, so people could just enter a lot of channels by regular expression and then get all the broadcast messages. This was so difficult to find that no team up to the end fixed it. A similar, little bit different vulnerability was here, where you got an SQL injection, and in the first place you just think, oh, wow, there's password. I got it from the CGI script. It's sanitized and then used in the query. And here just the last character. is the single quote. And so if people don't just check carefully, they miss it. And so you can still do SQL injection, and because with a backtick you can here escape the password and then just enter something like or1, and so it's sometimes quite viciously hidden. And sometimes it's just a little bit more stupid, like where you have a check, and even in the source code you have an encrypted flag and a plain flag, and if the length that you return is negative, you just get the plain flag, and otherwise you get the encrypted flag. These are things where you have to pay attention, that if you enter these things in your code, you might end up with some teams exploiting them very fast and others just don't find it. Some of the most difficult challenges that can be deployed in these capture the flag games are those where you have remote execution by design, like in the 22C3 capture the flag that has happened this morning, where you just could send shellcode to another team server that has to be executed because it's part of the service, and then you just get the return code. This is how it was programmed, and so the task is not how to prevent other teams to execute shellcode, because then the service is down, but you have to sanitize the code. Otherwise, you just shut down the service and you don't receive any defense points. And I think when the service was designed, there was actually no real clue how to prevent teams exploiting this service. And I even think that it's kind of impossible to prevent all possible exploitations of this, but
well, actually, there was one team really fixed it. They put it in this change root stuff.
yeah, but
This was quite nice in my opinion. So
yeah, it was quite nice. And well, depends on it. It worked for the capture the flag, but it 100% fixing is typically not possible. So yeah, the worst thing to happen is something like you have a service without source code that provides a service on the SSL that is encrypted in SSL, so you can't sniff the data, you can't read the source code, you have to reverse engineer the service. I don't know if this can be done in real time during a capture the flag game, but well, offline it can be done, of course. Additional possibilities to have the players more fun in the game is just assigning weak passwords, some backdoors in the image. It's surprising how little attention is paid to weak passwords. I think yesterday in the competition there were like 2 or 3 services having username equals passwords, and some teams took 3 hours to find that out. So yeah, just some more final small notes on capture the flag games. There are, for hosters at least, and for the participants, some common pitfalls. One of them is, just have small words here to remind me, is that there are sometimes teams that are unable to install VMware to set up their routing. And so if these teams can only participate if they give their root passwords to the organizers so that the organizers install the systems, this is something that typically should be avoided, but it happens all the time. The same applies to people that don't understand that they should hack the other team's boxes, but instead hack their own boxes, and if they submit the flags, they obviously always get the message from the flag server that these are their own flags, that they could have access with their own root password from their own machines, and after hours, they still submit their own flags. We also experienced that if we had some widely distributed capture the flag, that if in the vicinity of our university there was some intrusion after a CTF, people complained that that could have been some other teams that would like to take revenge for ours. This is just, well, if you participate in the capture the flag, just have some advice for the other people in your environment handy if they just complain that you or somebody else from the capture the flag hacked their system. And yeah, of course, capture the flags with too less or too much teams is obviously also no fun. From the technical point of view, there's just the typical points that can fail and spoil the fun out of capture the flag. The first is, of course, hardware and software failures. If hardware doesn't run, if software doesn't run, you're out of the game. Nearly no teams have some spare hot swap hardware or can set up a new software on the fly. Of course, side channel attacks on flags have to be avoided, so flags should be really random and not just something like MD5 sums of running integers or other predictable secrets. You should also avoid that people can sniff the other team's traffics, or otherwise they just sniff the flags that other teams submit and submit them their own. This also happens sometimes. Well, if you supply a VMware image, of course you have to take care that the keyboard layout is US and not German, that if the image boots for the first time, that it doesn't, the first thing that pops up is a FS check. You should delete all the vital information from bash history, and then of course make sure that no heat secrets for the players should be somewhere found in deleted files that can be found with the strings on def HDAR. Okay, so just finished this one so that I can very fast get over to the finishing procedure of this year's Capture the Flag and show the statistics. Are any questions so far? Okay, so here are the results, and is a little bit review on this year's 22C3 Capture the Flag. The planning of the Capture the Flag was quite short. We just had like 2 weeks to prepare for the Capture the Flag, and the image was ready the very minute where we started the Capture the Flag. There were also several weaknesses in the image that were definitely not planned, and but I hope that it was fun for everybody to participate. We had 6 teams, although we had 8 slots, but somehow the other teams got dropped out, and so here are some statistics for those who are quite interested. We can see here over the time that is the hour, like midnight, 1 a.m., 2 a.m., and here the services and the number of flags that, oops, that were submitted on this service. And as we can see, or at least the participants could have guessed, is that Passwordr was by far the most easiest service, where you could just punch in some usernames, passwords, and I think most of the flags were even word readable and could just be accessed by the Apache and typing the correct URL, and then bam, you got all the passwords. Surprisingly, the second easiest service was the distributed computing service, which I just showed a second ago. It just wonders us how long it took the teams to write a shellcode for it to just get the flags. Then, of course, there are the other services like the chat interface, which was quite popular, and just ESM got some flags covered at the end of the game. Sadly, nobody ever submitted a flag for auction, but I think this cannot be blamed on the players. Here's a little statistic: which team owned which other team, how often. In the upper row, we got the victims, and in the left column, we got the attackers. So like we can see that the Brotherhood of Pong only got one flag from the hectoliters, and that the hectoliters, in fact, were the best offensive team. In fact, I think that they only gave away 4 flags is mostly due to their large downtime. I'm sorry. Here's another display where we can see which team actually exploited which service. And well, surprisingly, EOF and LeChuck did not find the weaknesses in Passwordr, while EOF was the first team to exploit the very much more difficult distributed computing part. I think they could have got way more points by sticking with the easier services, but it's yes. Here's a overview on how the teams performed over the time, and a remarkable point is here where the hectoliters line stops scanning for like 1 hour. I think we all know why this happened. And yes, in fact, this is the one of the main reasons why they could not have or not have won the game. But as I said, it's running services at root is one thing not to do. So yes. I think the next slide already is the final score for those who haven't seen it yet. We have these 3 categories of offensive, defensive, and advisory scores. What I like very much is the fact that there's not a single team that rocked the complete contest by having top scores in all 3 categories, but just there's one team that is leading each category, and so it was quite interesting to watch the contest during the course of the time. And especially there were some very strong changes in the positioning in the last minutes. So it couldn't have had been better. Yeah. So I think this leads to the point where we can give the guys and the girl of There's No Base some presents for fighting so hard. Especially, I think it's a little bit of surprise that they won, because like the first half an hour they got not a single point and were just downtime. So where are the presents? And where are the winners? No winners? I keep the presents. We got sponsored by an operating system, so like next time yeah, the shirts are sponsored from Wim from OpenBSD, and I think, well, maybe the next time we should pay contribution and do the service not on Linux but on OpenBSD. So here's a set of shirts from the OpenBSD guys to the winners. Are there some words that you would like to tell to your mommy? Somebody of your team? Ja. Möchtet ihr was sagen?
Okay.
Ja, komm mal.
So, thank you very much for this wonderful experience. I never joined this before. It was my first time. Maybe some others have something to say? No? Okay. Thank you very much.
But of course, we got lots of more presents, at least for the second and the third team. If they are here, I don't know. If there's someone from the Brotherhood of Pong here? No? Okay. Oh, at least one. 2, 4, 4. Okay, here you got something that you can train for the next time where we promise to supply OpenBSD. I got a brand new OpenBSD 3.8 CD for you so that you can install and train. Find some 0 days and then rock the next contest. And is there any Chuck the Plant player?
Check the team. Check the team.
Okay, since you obviously are not as good as the second team, you needed to have it a little bit easier, so we got a bunch of OpenBSD 3.7 CDs for you, where there are more vulnerabilities included, so they're easier to find, more training.
Well, we certainly suck on the offensive. Do you want to make us aggressive or what? Well, thanks anyway for organizing the contest.